Chapter 2, Section 1.4, Part 4 video. These are the last examples within your homework on Section 1.4. This particular question says which of the table of variables which of the tables represent variables that are related to a linear function. Okay, for it to be linear, the slope, the rate of change, has to be constant. That means if we look at this, here's change in x, here's change in y. These are all increasing by 1, right? If they were decreasing, it would be by -1 if it was, for this. But from 20 to 24 is going up by 4. These are all, if you look at the ratios, change in y over change in x, every one of these are 4 over 1. So it's constant. Now, we done a problem, right here, that, right here. If you were to look, let me go back, you've got like 5 over 2, 10 over 4, 2.5 over 1, 7.5 over 3. If you were to simplify those, every one of these would simplify down to 2.5 over 1, which is really 2.5. So don't let things like this right here confuse you and say it's not linear. If you looked and simplified every one of them, they would simplify down to that, and that's a good check. On this one, it just happened to be that all of them were constant in the change in y's, and all of them are constant in change in x. But if they're not, list them out. Look at them in terms of a decimal, the change in y divided by change in x, and get it back to a unit rate for comparison. Okay, so are the variables related by a linear function? The answer is yes, because the rate of change is constant. But don't forget, because they may throw one out there, all of the changes are kind of scattered. They're not going up by 1 or something like that, like the example I just showed on the previous problem. Reduce those and you'll see it. Okay. All right. Geologists can measure the depth of an ocean at different points using technology called echo sounding. Scientists on board a ship send a pulse of sound toward the ocean floor and measure the time interval until the echo returns to the ship. The speed of sound in seawater is about 1,500 meters per second. Write the speed of sound as a ratio. Well, that would be 1,500 meters per is that line, is the division line. Okay, that's what per is. So that would be, and that's 1 second, right? So that would be A. Okay, if the echo returns in 2.5 seconds, what is the depth? Well, it would be 1,500 times 2.5. And when you do that, 1,500 times 2.5 is 3,750. And that would be meters. And the reason that works is this. Let me show you. 1,500 meters per second times 2.5 seconds. If you remember back in your days, these units cancel out, right? So that leaves you with 3,750. So that's another way to think about it. All right. So let's look at this one. They're going to give you a quadratic, no big deal. But we have to, I'm going to show you how to do this on the calculator. What they're wanting us to do is to evaluate these x's. And x would be -4 and the x would be -1. And they want us to turn around and do it again as -3 and 3. And then find the slopes of each one. So what I want to do is I want to show you how to type in this equation right here into your calculator and evaluate those. That way it's a lot cleaner. Okay. So let's go to our calculator. Let's go y equals. if you have any equation, just hit clear. So we're going to go x, here's the squared button over here, plus 2x minus 7. So if you follow this key press history and look at your screen and then watch the video as the buttons that I press turn red, you should be able to have that typed in. Now, we're going to go to table setup. Its own ask, meaning when I go to my second graph, when I go to table, there's some variables already there. I can input the x values that I want and only the ones that I want, okay? Instead of populating a list like Auto would do. So we need -4, the negative's down here, and then -1, okay? And let's go ahead and get -3 and 3. So, -4 gave me 1, and -1 gave me -8. -3 gave me -4, and 3 gave me 8. Alright, so what we're going to do is now we're going to go back and we're going to write these in, okay? So we're going to say there's 1, there's -8, here's -4, and here's 8. So we're going to look at changing x and changing y. From -4 up to -1, that'd be a positive increase of 3. From 1 down to -8, that would be -9. And the reason it would be negative is because you're going down the number line. 1 down to -8 is 9 spaces, but it's in the negative direction. So slope would be changing y over changing x, which would be -9 over 3, which would be -3. So the slope on the first one's -3. Now, let's do this one. From -3 to 6 is, or -3 to 3 is a +6 change. From -4 to 8 would be a +12. Okay, so slope, changing y over changing x, which is 12 over 6, which is 2. So what you're doing is, this quadratic, they're having you evaluate some x's and just find slope of the individual 2 points. Now for a quadratic, the first rate of change is not constant, okay? For a quadratic, you have to look at what we're talking about, the derivative, and that's way above what we normally do. It's a lot of theoretical stuff. So for the main part, you plug in your x's, get your y, and find slope. Then go to the second problem, plug in your x's, find y's, and calculate slope. So this concludes all of the homework that you have in section 1.4. This is part 4's video.